Hi viewers, welcome to my channel. This is Anthony Vijay. Today we are going to discuss about from the topic Vernam Cipher. Let's see about the introduction about Vernam Cipher. So Vernam Cipher is a binary based symmetric encryption technique which is invented by the Gilbert Vernam in the year of 1917. It works like combining the plain text with a random key using XOR operation. Let's see about the key points. In this, each letter in the plain text is converted into the form of a binary, that is zeros and ones, and random key will be generated for plain text based on the length of plain text. So the length supposed to be same, and this particular random key is mixed with the message using XOR operation. The final result will be the ciphertext that look like a random data. Let's see why it is so special. If the key is truly random and the length is same as the plain text and it is only used once, so the Vernam cipher becomes unbreakable and it is a different version of one-time pad. Let's see the example for Vernam cipher. Let's see the encryption part of Vernam cipher. So first of all, we are taking the plain text, which is hello. So it contains 5 characters. The second step is we have to convert the plain text in the form of binary. So H is converted into ASCII form, that is 72. Then again 72 is converted in the form of binary. Let's see how to find ASCII to binary. So here I am taking 72. 72, I am applying the dividend rule. So it is 36. The remainder is 0. Then again I am applying 2. It is 18. Again it is 0. Then 2. It is 9. Again 0. Then again applying for 2. It is 4. Remainder 1. Then again 2. 2 into 2, 4. The remainder is 0. Again I am applying 2. So 1 into 2 is 2. So the remainder is 0. So we have to apply in this direction. So here 1, 2, 3, 4, 5, 6, 7. So here we have to form 8 bits. Here it is only 7 bits. So 1, 0, 0, 1, 0, 0, 0. So in the prefix you have to add one more 0 to form 8 bits. So likewise you have to create for E, L, L, O. So for example, let's see, try for 79. Okay, once again I try for 79. So once again I am applying this rule. So this is 39. 39 into 2, it is 78. So 78, the remainder is 1. Then again I am applying 2. So 19 2s are 38. Again remainder 1. Then again applying 2, it is 9. 9 2s are 18. Remainder 1. Then again applying 2, it is 4. 4 2s are 8. Again remainder 1. Then 2 2s are 4. Remainder 0. Then again 2, it is 1. Remainder is 0. So here in this direction you have to write. So for this 79, the value will be 1 0 0 1 1 1 1. So again 1 2 3 4 5 6 7 digits. So I have to put 1 0 here. So let's see the answer. 0 1 00 and 4 ones. So in this way we have to convert from ASCII to binary form. So in the third step we have to take random keys for the plain text. So plain text length is 5. H, E, L, L, O. So 5 characters are there. For each and every character, we have to assume one random key. So for H, we have to apply K1. For E, K2. For L, it is K3, and one more L is there, K4. And for O, it is K5. So random keys should be generated for the same length and based on the size also. If the character is 6 characters, you have to add one more key also. But here only 5 characters, so we need only 5 keys. Now we are finding an encryption technique. Here we are following bitwise XOR operation. When I talk about XOR truth table, So 0 0 will be 0 and 0 1 will be 1, 1 0 will be 1 and 1 1 will be 0. So in these two cases you will be getting 1. So now we have to form a table like this. So already we got plain text to form. This is H, this is E and L, L, O. So here H is converted in the form of binary and key we are having K1, K2, K3, K4 and K5. So now we have to apply XOR. So this H XOR K1. So this is the example H XOR operation with K1. So here H is 0 1 0 0 1 0 0 0 1 0 0 1 0 0 and for K1 1 0 1 1 0 1 0 1 0 1 1 0 1 0. Okay, now we have to apply XOR rule. So 0 0 is 0, 0 1 is 1, 0 1 1 1 0 1 0 1 1 0 1 1 1 0 1 0 1 1. So this is the value that is called 254. For the 254, the ASCII value here is, it is black square. It is a black square. So likewise we have to repeat for E, L and L, O. So you will be getting a different values like 40, 143, 80 and 229. For 40 you are getting a square bracket like this, and for 143 you are getting Latin capital letter A, and for 80 you are getting P, and 229 you are getting sigma. It is a small letter of sigma. Okay, so finally our ciphertext will be like this. So this particular ciphertext will be in the form of random one. So intruders will not able to find this. Let's see about the decryption part. So in this decryption part we have to reverse the process. That is ciphertext. Right now we got ciphertext and XOR with the key. That 5 keys are there. Na? Now I am applying XOR operation with the ciphertext and key. So I am taking the ciphertext now. So it is 7 ones, 3, 4, 5, 6, 7, then 0. Now I am taking K1 here, K1, that is 1 0 1 1 0, again 1 1 0. So this is XOR operation. 0 0 is 0, 1 1 is 0, 1 1 is 0, 1 0 is 1, again 1 1 is 0, 1 1 is 0, 1 0 is 1 and 1 1 is 0. So you are getting like this. So this is the result. So finally we got 72. 72 means H. So we are returning the plain text H E L L O. So finally we got the plain text back. So this is called Vernam Cipher. Likewise we can change the random keys, so you will get different results.
Please like and subscribe to my channel and press the bell icon for regular updates. Thank you very much for watching.